But what we're going to learn about today are different polynomials and how to sketch them. So here's our first example. Y equals x times x plus 1, x minus 2, x plus 3. So the first question was determine the degree. If we multiplied that out, we would have x times x times x times x, which would be x to the fourth. So this is an even function. So that means that when we finish, we should have a graph where either both ends point down or both ends point up. Okay? So that gives us an idea of what it's going to look like. Secondly, let's determine the y-intercept. In order to find the y-intercept, that is when x is equal to 0. So plug in 0 for each x, then solve. In this one, it's going to be relatively easy because there's an x out front, which means that no matter what I multiply by, everything's going to equal 0. But this ends up looking like 0 times 0 plus 1 times 0 minus 2 times 0 plus 3, which equals 0. So therefore, the y-intercept equals 0. So what that tells us is that on our graph, it's going to go through 0. It's going to go through the origin. Next, we're going to find the roots. The roots are basically found by using the zero product property for each of those terms, or each of those factors in what we're talking about. So in this case, we would say x could be equal to 0, x could be equal to -1, x could be equal to +2, and x could be equal to -3. So I got all these by setting factors equal to 0. And remember, these are the factors. X, x plus 1, x minus 2, and x plus 3. We know that it's even. We know that it's going to go through the y-intercept. And we know that these are going to be the roots. Now, what roots actually means is where the graph crosses or touches the x-axis. So in order to figure out what our graph is doing around those places where it touches the x-axis, what we're going to do is create a sine graph. So a sine graph is basically a number line, and on our number line we put the roots. Okay, so we've got -3, -1, 0, and 2. Because what we're mostly interested in is the space in between those. So for each of those curves, for each of those points, I'm going to put a little dashed line. Because I want to know, what is my graph doing in between each of those points where it's actually touching the x-axis? Okay? And the way I do that is I choose a value that is in that area that I'm interested in. So for example, if I am looking at this area over here, what I want to choose is a number that would be less than -3. So we can choose like -4. And what we do is we plug -4 in for x. So plug in -4. And what I'm going to test is all of the possible values. So remember, our original function was x times x plus 1 times x minus 2 times x plus 3. Okay, if I put in -4 for x, that's a negative. If I put in -4 for x plus 1, Well, that would give me -3, so that's still negative. If I put in -4 for x minus 2, that would give me -6, so that's still negative. If I put in -4 for x plus 3, that would give me -1, so that's still negative. But if I have 4 negative numbers and I multiply them all together, what sign will I get? Well, negative times negative is positive, times negative is negative, times negative is positive, right? So this ends up being positive. So on my little sign graph, I'm going to put a positive in a circle above the number line because that's where the positive numbers are, right? Because what we're figuring out is our graph is our curve going to be above the x-axis or below the x-axis? So from negative infinity to -3, our curve is above the x-axis. So now let's look at this area. So we need a number between -3 and -1. Well, the obvious choice is probably -2. So we'll take -2. If I plug in -2 for x, I get a negative. Plug in -2 for x plus 1, I still get negative. Plug in -2 for x minus 2, I still get negative. Plug in -2 for x plus 3, I get positive. Haha. So if I multiply negative times negative, that gives me positive. And then that positive times negative would be negative. And negative times positive equals negative. Okay? So in this area, we're going to have our graph be below the x-axis in negative territory. So now we keep going. So now we need to pick a value between -1 and 0. So now we're in this area. Logical choice probably -1/2, but you can choose whatever you want. It doesn't really matter because mostly we just need to figure out the signs. So if I choose -1/2, that first term would be negative. The second term would end up being positive. So that term is negative. So it's negative, positive, negative, positive. Okay, so if I have 2 negatives, that makes it positive. Everything else is positive, so this is positive. So we are positive in this area. Okay, next we look here. In between 0 and 2, logical choice would be to choose 1. So if I choose +1, the first term is positive, second term is positive, third term negative, fourth term positive. So this whole thing ends up being negative. And finally, we need information from numbers that are greater than 2. So this area here. And if we choose, say, 3, for the first term, it's positive, second term, positive, third term, positive, fourth term, positive. So everything is positive, so we are positive. So you have to do that in order to figure out what your graph looks like. Now, if you've done your sign graph correctly, you should be getting an idea of what this curve is going to look like. Okay? And now we can actually just sketch it. So we'll draw our set of axes. Now we do want to put our numbers on in a scale. So if this is -1, this would be -2, -3, 1, and 2. We know that our graph is going to go through -3. It's going to go through -1. It's going to go through 0. And it's going to go through 2. And we know that our graph on the left side of that -3 point starts in a positive area. So we're going to start up here in the second quadrant, and we're just going to curve down through that point. Doesn't really matter how far you go. Turn around, we're going to go up. Doesn't matter how far you go, we got to go back down. Then we go up. And then we put arrows on the end of both of them, and that is our sketch for the polynomial x times x plus 1 times x minus 2 times x plus 3.